Okay, so this is the last part of the paper. Now, once you see how this is done, it's not that bad, but it's certainly a confusing question, and it took me a while, again, to get my head around what they were actually asking. So, here we go. The written assessment is in 5 sections, 1 to 5. At the end of the year, the employees are also given a score for each of 5 professional attributes, V, W, X, Y, and Z. The firm wants to know, they decide to test the hypothesis that there is correlation between the mark in a section and the score for an attribute. They compare marks in each of the sections with the score of each of the attributes. I think each is bolded in the exam paper because that's important. Write down the number of tests they carry out. There's 1 mark for this, guys. So this took me a while, again, to figure out, even though once you see it done, it's quite easy because it was just the wording of the question. So they compare each of these. So he's going to compare section 1 to the attribute V. And then he's going to do section 1 with the attribute W. Then section 1 with the attribute X. 1Y, 1Z. Then he'll do 2V, 2W, etc. I'm not going to write them all out. What you get is, for part 1, there's going to be 25 tests because it's just 5 times 5. There's 5 ones, 5 letters, 5 times 5, you're going to get 25 tests. Okay, part 2. He says, assuming that there's no correlation between the marks in any of the sections and any of the scores in the attributes. So essentially, they did imagine now they did the tests and there was no correlation. They found out, so they were testing the hypothesis that there was correlation between a mark and a score, but there wasn't. So we're assuming now there's no correlation. And the outcome of each hypothesis test is independent of the outcome of the other hypothesis test. Find the probability that at least one of the tests will be significant. So he's basically saying, even though that the point of this question, the point they're trying to get at is, even though there is no significance, because we're doing 25 tests, we're actually probably one of them will end up being significant. Sorry, I should have said, because there was no, or even though there's no correlation between the numbers, or in any of the tests, between any of the numbers and any of the attributes, there was no correlation, you still might get basically a flawed test, a significant test, even though there's no correlation. That's the kind of point they're getting at here. And the way we're going to do it is we're going to let this whole thing be a binomial distribution. So guys, I don't want to choose, normally I would choose X, but they've already used X, so I'll just let it be T. I forget what they use in the mark scheme, maybe it's T. Anyway, let T be a binomial distribution. Now I know it's binomial because there's 25 tests, so that's our fixed number of trials. I have a probability, 0.05, and they say each test is independent of the other test. So you need that for binomial distribution. You need a fixed number of trials, you need a consistent probability that stays the same, and you need all the tests to be independent. So that's what kind of tells you it's binomial. So then T is a binomial distribution with 25, and then I just need to find the probability that T is, he said, find the probability that at least one will be significant. So that's T is greater or equal to 1. And I can just do this on my calculator. So I'm going to go to menu, probability, distributions, binomial CDF, number of trials is 25, probability of success 0.05, lower bound is 1, upper bound is 25, press OK, and I get 0.72261. 0.72261. And that's it. That's the probability that at least one of them will be significant. 0.723. And then finally, and this is what I mean by the point of this whole question, he says, the firm obtains a significant result when comparing section 2 of the written assessment and attribute X. Interpret this result. So imagine they run all these tests and none of them are significant, but here they go, actually, it appears in section 2 and attribute X, we have this correlation. This seems to be like a really significant, these two are related, but really, that's probably not the case. It just so happens that they did so many tests, they were probably going to get one. They were probably going to get one significant result. So, what does he say? Interpret this result. Probably, I'm going to say probably not meaningful as, and I want to refer back to this value here, as there was, let's go with percentage, is 72.3% chance one test would be significant. So as I say, yeah, it's not that big a deal. It doesn't mean that these two have this big relationship. It's just it was likely there was going to be at least one significant result. Okay, that is paper 3, guys. I would say I think question 2 was actually easier than question 1, provided you understand your statistics. Question 1 was hard. Question 2 I think was definitely manageable for everyone, even if it's definitely confusing at times, but I think everyone should be capable of getting most of the marks there. Okay, guys, I'll see you in your next video, whatever that is.